Hello everyone, in this video I would like to make a video tutorial how to make a vegetation health index analysis in mangrove area like this figure. So the data I use is Global Mangrove Watch as my max layer, and also the primary data from Sentinel-2 image MSI, and also MODIS LST. So the first thing that you have to do is import GMW and import EE. Okay, next step, you have to make sure you already have a Google Cloud account, so you have a project that will be connected in the Google Colab code editor. So how we can do that? So the first, you have to authenticate your Google Cloud data, and then you have to go to the GitHub of the XEE and focus on this code and copy this code into your Google Colab editor and write your project. So my project is has Usaini, and don't forget to put comma in front of your project. So after that, the the Google Cloud has been connected in the Google Colab code editor. So next step, you have to define your base map. So how we can do that? So we just write GE map multiply map and choose your base map or whatever you want. So like this, I want a base map in a satellite mode. So I choose base map, and next I write satellite. Next, and next, how can we visualize, how can we call the map, the base map? So just write a map, and then you can choose uh, where your area of interest, where your region of interest are up to you in the anywhere of the area. So in this analysis, I choose in Medan city of the mangrove area in Medan city. So after that, when you have your area for the analysis, you have to define your area like this. So my area I define with ROI, and then I draw last feature, and I multiply this with geometry. Don't forget to uh, write this. Okay, after that, you have to go to the Global Mangrove Watch data, and you copy this code and go back to the Google Colab code editor and paste the code in this area, this column. So don't forget to define your column. So I define this as a mangrove like this. After that, we cannot clip the image collection. So we make sure that the image has the single image. So why can we change the image collection into the one collection? Watch this. Okay, we just write in single image as a definition, and after that you have to write mangrove, and also and next you have to define your median like this. Whatever you want, like median, mean, or anything. So I just want a median in here, and next you have to right click to your ROI like this. So you want to see the data in the base map in the interface. So we just write map at layer single image, comma, and just define your you just make a definition of your data. So I in this code I define mangrove. Okay, let's see in the base map. So we have a mangrove single image data in this layout. So in this base map, so we just focus on this area, and we just calculate VHI in this area using Sentinel-2 image and MODIS LST. So next we have to define index and VHI, and we convert the LST format into Celsius. So why can we do the two index? So the first, I would like to calculate NDVI like this. Okay, don't forget to change this band into H and 4, because in Sentinel, red and green in a band H and band 4. Okay, and don't forget to make the copy properties, because this is important thing to make a time series data like this. Okay, and next I would like to convert land surface temperature from MODIS into Celsius format. So why can we do the convert? So we just calculate LST, we define the definition, and choose the image. Next, LST and image, select LST day 1 kilometer. Next, we multiply multiply 0.2 and subtract 273.15 and we rename to LST. Don't forget to make a copy properties because this is the important thing to make a time series data. Next, we make definition in Vegetation Health Index. So calculate VHI. In this index, we choose NDVI image and LST image. So we put the NDVI image and also LST image. Next, we have to define my NDVI mean value from the image and also NDVI max from the image related to LST max and LST mean. So we have to define LST max and LST mean as well. So next, how can we do that? So just write this code I mean and we just define NDVI in this collection. I would like to make the name of the image NDVI. I will make the image name NDVI collection, and I select the band NDVI and I put the mean value. Next, max NDVI collection, select VHI max, and I will do the same in LST. Okay, after we define the NDVI mean and max and also LST mean and max, we have to define FCI NDVI image, subtract NDVI mean, define NDVI max and subtract NDVI mean, and we define LST max, and in this subtract column we change to LST image. After have done, right, the FCI and LCI, we have to define FHI, FCI, and LCI divide 2, and next we rename into FCI, and don't forget to put the copy properties in NDVI image, and we put the system start and system end. Sorry. Okay, after this we run this code. Sorry, this is okay. I forget to put this code in this column. So run this. Okay, we successful run this code, and next we have to call the Sentinel image, and we have to call the MODIS image into Google Colab code editor. So how can we do that? So in this, because I put NDVI collection as a name of NDVI image in this column, so I have to copy this name into this column. Okay, next. Okay, go to the Earth Engine data catalog and copy the harmonized Sentinel-2 MSI in this code into this code editor in Google Colab. So filter date 2018 until 2025. Okay. Next, we multiply with the calculate NDVI. Next, we do the same in LST collection. Okay, we run this code. sorry, forget to put the this code in the last column, the last code. Next, okay, we have an NDVI collection and we have LST collection. So next, what we will do to calculate the vegetation health index, we have to put in this code like this. Okay, before we make the single image for each year, I'm sorry, I forgot to filter this image, filter the cloud percentage. So how we can filter the cloudy percentage from the Sentinel-2 image. So we got data that clean from the cloud. So how can we do that? So like this, filter, understand, cloudy pixel percentage. So we filter the data, the Sentinel data, with a cloudy pixel percentage band less than 20. So just I'm sorry, just run the code. This, okay. After that, we make the single image by each year. So how we can do that? So just NVI collection 2080, filter that and choose median or mean, up to you, because we often use median in GIS spatial analysis. I just want to choose median in this analysis. I also choose median in this analysis. So next, we select the LST single image. We make a single image from the LST. So we can filter the data by the year. So just replace this code like this, and then I copy, because we will make the time series data. So I just copy for my code into this Google Code editor from 2018 until 2024. The data just have one single image. So let's copy all the data this, and I just want make the name same as the next year like this. Okay. Next, we got the single image by each year. So we make this image, we convert this image into image collection. So we just write the code like this. First, we have to define image date, image.str. This image that str. Yes. Next. Okay. Return image set system start and system. Sorry. I'm sorry. Set and ee date that str. Sorry. Str. Okay. That's correct. Okay, I'm sorry. Okay. 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 So next, we have to calculate our vegetation health index. And now, just write like this. Image 2018. Next, because we want the data have a date properties in the band of the data, we have to make the image with date into the data. So why can we make the data have a date? So like this, we just write image with data, because we have defined it, the image with data, from the first, from the code, the first code. So the first code on the column. So like this, let's calculate VHI, median, LST, median, and DVI 1018, and LST and median, LST 1008, and we define our date like this. uh, 12:31, and we try to run this code. Okay, so we have a lot of data in here, so I just copy from our data, or for our last code before, so we can efficient the time to write all this code. Okay, we try to convert the image collection, the image data into the image collection using EE image collection format, and we put all of this code into one image collection. After that, we have to make the image clipped by region of interest. And now we just print the code of the VHI, Vegetation Health Index, like this. Okay, okay. We have a 7 element in here. The first is for the 2018 until the 6th for 2024. After that, we just import X-ray SXR, okay, and matplotlib as a PLT. Let's go there. Now we try to convert from the raster data into X-ray data using X-ray package. So how can we convert the data? Okay, open dataset AA as our image, and engine we choose EE as our engine, and next we choose CRS or coordinate system APSG 4321, and next we put the scale. We manage the scale. In the scale we choose a Sentinel scale, that is 0.0001, and as a geometry ROI. Close the code. This. Okay. Okay. Next. We can visualize the data from the X-ray format that was converted into X-ray format. So we can visualize that using matplotlib. So how can we visualize the data? So first we have to put DS in here. So we choose the band FVHI and multiply plot and define a coordinate X as long and Y as lat. And next we need to define our color. So I define for the color of the area, I put RDYIGN, and for the cool I use time, and next for the cool warp I choose for column for this plot. So last is I define robust true and run this code. Okay, maybe it take a minute for running the code, because that is contain a lot of data, because we use scale 0.0001, so maybe it take a minute. Okay, Okay, we have some issue in here, so we uh, just repair for the Gmap. Okay, maybe okay, okay, I use Fury this. Okay, okay, maybe it takes a minute for the for writing is good. Okay, I'm sorry for this. Okay, uh, my map has been analyzed using Vegetation Health Index. So we can look at the bottom value. We have a 30 in the bottom, and the upper we have a 70. So in this area we have a good vegetation health, and in this area we have a bad health vegetation. So this is the final look, the final figure of our analysis. So thank you for watching, and don't forget to subscribe and like my YouTube channel and my video. Thank you.